Hello students, and welcome to the part 3 of Fundamentals of Computer video series. In this part, we will be discussing about the data representation and Boolean algebra. Let us have a look at the contents of this unit 2. In this unit, we will be discussing about number system, binary, octal, hexadecimal and their interconversion, ones and twos complement, binary arithmetic and number systems with BCD, EBCDIC, ASCII, De Morgan's theorem, duality theorem, K-map with sum of product and product of sum, algebra rules, laws, and finally we will be learning how to draw the logic circuits by making use of gates, logic gates such as NOT, AND, OR, NAND, NOR, XOR and XOR. Before we begin, let us first try to understand what is number system. Number system is a technique which is used to represent numbers in the computer system architecture. Every value that you are saving or getting into or from the computer memory has a defined number system. The typical number systems which we know are binary, octal, decimal and hexadecimal number system. Now let's begin first by studying the interconvergence of this number system. First of all, we will learn the steps for converting any base to decimal. The steps for converting any base to decimal are as follows. First step, identify the base of a given number. Second step, assign the weight to individual bit according to their location. Step 3, multiply the bit with the base having power as its weight. And step 4, add all the values to get the decimal equivalent of given integer number. Now of course we will try to understand these steps by making use of one example. So let us take an example. We have taken a binary number and we will be learning these steps to convert this binary number to decimal equivalent. The number which is given is 101011 in binary format. So first of all, as per our step number 1, identify the base of a given number. The base is 2 as the given number is binary. Step 2, assign the weight to individual bit according to their location. Now weight is decided as per the base of that particular number. Since here the number which is given is binary, so our weight will be 2. And now what we are going to do is assign the weight to individual bit according to their location. Now very importantly, before we assign the weight and multiply the bit with the power of that particular weight, please focus on the direction we will be following. We will start from right to left. So we will take this rightmost bit, multiply it with the power of 2, 2 raised to 0, then second rightmost bit, multiply it with power of 2, 2 raised to 1, 2 raised to 2, 2 raised to 3 and so on till we actually cover all the bits from right to left. And then we are going to add all these values to get the decimal equivalent, which is 43. Now we will be learning the steps for converting fractional part from any base to decimal. Let us first go through the steps for this conversion. First, identify the base. Second, assign the weight to individual bit starting with -1 and moving towards -2, -3 as per the number of bits given. Multiply the bit with base having its weight as power, and step 4, add all the values to get its fractional equivalent. Now in this conversion we need to actually understand two important things which we will try to see with the help of example. The example which is considered here is a binary number with fraction. The number which is given is 101.1101. Now here we need to understand how to convert the two parts of this number, the first part and the fractional part. So let us again go through the steps. First, identify the base. So here again the number is given as binary number, so the base is 2. So first of all, when we want to convert the first half of that number into its decimal equivalent, follow the same steps as earlier. So again here we will start with the rightmost bit, multiply that particular bit with the power of 2 starting with power as 0, 1, 2 as per the number of bits, and so the first part we will get as 5. The decimal equivalent of the first part is 5. Now in this slide, very important point is how to convert the fractional part. So for converting the fractional part, there are two things you need to remember. First is we will be multiplying the weight, we will be considering weight to individual bits starting with -1 and moving towards -2, -3 instead of 0, 1, 2. And second very important thing which you need to remember is here we will multiply each bit with the power of that particular weight starting from left to right direction. So here we have started from the leftmost bit, that is 1. 1 into weight is 2, and the power we have taken as negative, that is -1. So 1 into 2 raised to -1. Then the second leftmost bit, that is 1 into 2 raised to -2, 0 into 2 raised to -3, and so on till we cover all the bits. And then of course we have to add these values. The number which we will be receiving is 0.8125. And the last step is very important while writing your final answer. When you are writing the final answer, you have to write the given number with the base is equal to the first part, of course, 5.8125 as your final decimal equivalent of the given binary with fraction. So these are the steps for converting a binary number with fraction to its decimal equivalent. Now you must have observed one thing here, that you need to remember the negative power of 2 here. So for that I have created one chart to make you remember the negative power of 2, such as 2 raised to -1 is equal to 0.5, 2 raised to -2 as 0.25, 2 raised to -3 as 0.125, and so on. So majorly it is expected that at least you will be able to remember up to 2 raised to -5. So that will be easy for you to add up the values in your last step. So here we will wait today. Please practice on these two conversions, and then next part we will be continuing with the further portion. Thank you very much.